So we would all like to keep secrets by encrypting them. But time and again in history, we have seen that many of these crypto systems and encrypting methods have been broken. Way back in the Roman times, an example that used to exist widely was the Caesar shift cipher. It's a substitution cipher where you just swap one letter of the alphabet for another one. And the precise way to do this is just by shifting the alphabet. So if you had D, you would replace it by A, E by B, and so on. And hopefully now your secret message looks like gibberish that no one can understand. Well, it looks like the game is done, but this is actually easy to decrypt. So we run into problems again. And the simple reason is that in every language, letters occur with distinctive frequencies. For example, in English, you have the letter E, which occurs with like about 12% of the time, which means any alphabet in your ciphertext which occurs with the same frequency could be guessed for being E. And then you replace it, and then with a few more tricks, voila, you have the whole message decoded. No more secrets. Now, thankfully, in practice, we have much more sophisticated crypto systems. One used on the internet is called RSA, and this actually survives or relies on the fact that it's very hard to factor large numbers. And there are also other crypto systems which basically rely on the fact that many math problems are hard to solve. Now, factors are these two small numbers which you want to multiply together to give you a big number. A simple example, 21 is just 7 into 3, and 6 is 2 into 3. Now, the easy ones are just multiplication tables, right? But what happens to the really big numbers? Don't start counting, but this guy is about 232 digits long and would take more than 750 bits to write in a binary code required for the computer. So factoring this number actually took 2 whole years on a computer. Thankfully, in practice, RSA uses much larger numbers in its crypto system. So we should feel safe that our secrets aren't going to be spilled out. That's what I thought until I stumbled onto the world of quantum computers, where scientists have actually come up with many ways to factor numbers much quicker. Well, quantum computers aren't a reality just yet, but there are a lot of people working on trying to build it, especially because it allows us to also solve other neat problems. So now it seems like it's a downfall of encryption as we know it. But as they say, one door closes and another one opens, and quantum cryptography is going to be our way out. Now, in this case, the hardness or security of the crypto system doesn't depend on how hard it is to solve a particular math problem, but is based on the laws of physics, especially the way particles behave. So, in a sense, in principle, they are unbreakable, and that should help keep us and take us into the future.